Today we're going to be talking about investigating transformations on quadratic functions. So if I look at the first part of my notes, it says complete the table to make an accurate graph of the quadratic parent function. Y'all should know the quadratic parent function is y equals x squared. So I want y'all to copy down the table and I want you to plot the points in order to graph the quadratic parent function. The next thing says, in the items that follow, use a graphing calculator to compare the graph of y equals x squared to various transformations of this parent function. We're going to sketch the graphs and then we're going to discuss the conclusions. If you don't have a graphing calculator, that's okay. I will actually have the graphing calculator on the video for you to see exactly what happens. So I want you to copy these down and let's look at problem number 1. All right, problem number 1 says in y1 I'm going to type in x squared and y2 I'm going to do negative x squared. So we go to our y equals, we make sure everything is cleared out of our y equals. In y1 it tells me I'm going to type in x squared. In y2 I'm going to type in negative x squared. And then I want you to hit graph. So what you should notice is that my calculator matches the sketch of y equals x squared and y equals negative x squared. So based on the conclusion we should make, I want you to copy down what's in the box. The negative in front of the x squared causes the function to reflect over the x-axis. Okay, so if I have a negative x squared, it doesn't do anything to the problem other than it's going to reflect my graph. Okay, so it says a parabola inverts and turns downward. So this second graph, the one on the bottom, is going to be my inverted or my negative x squared. Okay, so let's look at the next one, problem number 2. It says I got y1 is equal to x squared and y2 is equal to x squared plus 4. So let's enter those in. Okay, so in problem number 2, we're going to enter in y1 x squared, and in y2 we're going to enter x squared plus 4. So let's hit graph. So if I notice, my first graph should match what's already dotted on your graph on the paper. And then if you notice, my second graph is the x squared plus 4. So what happened to that graph? You should have said that the function had a vertical shift of 4 units. So I want y'all to copy that down. Okay, it had a vertical shift, meaning it moved up 4 units. So if I have a plus 4, I'm going to move up. What would happen if I had a minus 4? All right, let's look at problem number 3. Problem number 3 says y1 is going to be x squared and y2 is going to be x squared minus 4. So what do y'all think is going to happen? If the plus 4 moved my graph up, what's going to happen to the minus 4? You should have said it's going to move it down. Okay, so on number 3, I should have that the function has a vertical shift down of 4 units. All right, so let's look at problem number 4. Problem number 4 says I got, for y1, I'm going to have x squared, and y2, I'm going to have in parentheses x plus 4 squared. Okay, so let's plug that into the calculator. If I go back to y equals, and in y2, I'm going to type in parentheses x plus 4, and I'm going to square that. So when I hit graph, your graph should match the sketch that I have on my answer key. Now, if you notice what happened to my graph, you should have noticed that there was a horizontal shift, meaning it's going to move left and right. Now, this one was minus 4, or excuse me, this one was plus 4, but what direction did I actually move? I moved to the left. So what you should notice is whenever I move horizontal, I'm actually moving in the opposite direction. So if I have a plus 4, I actually move 4 units to the left. So look at number 5. If I had x minus 4 in parentheses squared, if it's a minus 4, what direction should I move? You should have said I'm going to move right. So looking at problem number 5, when I graph x minus 4 in parentheses squared, the function is actually a horizontal shift to the right. So if I move horizontally, okay, it's going to shift in the opposite direction. Okay, so let's look at number 6. I have y1 is x squared and y2 is 2x squared. Let's plug that into the calculator. So if I go back to y equals, and I'm going to have 2x, I'm going to type in 2x squared. Okay, so when I hit graph, what do you think happened in problem number 6? Y'all should have noticed that it got a little bit wider. Okay, or excuse me, it got a little bit narrower. So from here, you're actually going to use this, and you're going to write it like this. On problem number 6, I should have that the function stretches vertically by a factor of 2. It is a vertical stretch by a factor of 2. So if I have a number in front of my quadratic, it is a vertical stretch, and whatever that number is, it's going to be by that factor. Okay, so let's look at number 7. Here, I still have y1 is x squared, and y2 is actually 0.5 x squared. So what do you think is going to happen here? Let's plug it into the calculator. If I go back to y equals, and I plug in 0.5 x squared, when I hit graph, what do y'all notice about this graph? You should notice that it got a little bit wider than the first graph. Now here, if I have a fraction, so like for instance, I have 0.5, this is actually called a vertical compression by a factor of 0.5. So let's talk. Number 6 was a whole number. It's going to be a vertical stretch, and if it's a fraction or a decimal, it's going to be a vertical compression. Okay, so what I want y'all to do is turn to the last page of your notes, and we're going to kind of reflect and summarize what we just talked about. Okay, so based on what we're looking at, it wants us to tell how the functions below are different from the parent functions. So problem number 1, we had y equals negative x squared. Remember we said it was going to be a reflection over the x-axis. My domain is all real numbers, and my range is going to be y is less than or equal to 0. Let's look at the next one. The next one I have y equals x squared plus 4. This is where we had a vertical shift up 4 units. So my domain is still all real numbers, and my range is y is greater than or equal to 4. The next one, I actually had a vertical shift down because it was minus 4. So here my range is y is greater than or equal to negative 4. Okay, when I had x plus 4 in parentheses squared, this was a horizontal shift. Remember, it was left 4 units. So it was plus 4, but I really moved to the left. So here my range is all real numbers, or excuse me, my domain is all real numbers. Okay, so my domain is all real numbers, and my range is y is greater than or equal to 0. Same thing with the next one. I had a minus 4, so we really moved 4 units to the right. Okay, and copy the domain and range. When I had 2x squared, it was a vertical stretch by a factor of 2. If I have a coefficient in front of my x squared, and it is a whole number, it's going to be a vertical stretch. And then the last one was 1/2 x squared. Remember, if it's a fraction or a decimal, I have a vertical compression by that factor. And for both of those, the domain is all real numbers, and the range is y is greater than or equal to 0. Guys, copy all of this down. You should have these notes done before y'all get to class.